Now this is module 2, which will be on AC DC rectifiers. Module 2, AC DC rectifiers. Fine. Now, very broadly, rectifiers, they actually convert input AC to, I will write it as fixed voltage, fixed frequency. FF refers to fixed voltage, fixed frequency, AC. This is the input. Now this is being converted into, you will have variable voltage. Actually frequency will not change because it is DC. So fixed frequency to variable voltage. I will write it as fixed frequency, but you will understand that DC doesn't have any frequency. Therefore, the term FF is going to be, or for clarity, I will avoid this and write it as variable voltage DC. Obviously, VV refers to variable voltage. Better to avoid the term fixed frequency, then it may cause a confusion. So if you have fixed voltage, fixed frequency AC, you get a variable voltage, variable voltage DC at the output. That's all. Very generic term. Now, if you want variable voltage, this is the key. If you want variable voltage, you must use controllable devices. Then must use controllable devices. Which means power diode is out of the equation because we want variable voltage at the load end. So diode cannot have control. Therefore, you can't obtain variable voltage at the DC side if you use a power diode. That is out of question. You can use an SCR, MOSFET, IGBT or transistor. One among them, fair enough. This is the first point that you need to understand. Next point, control the devices. Now, the devices are actually controlled using gate control principle, gate control. Now, this is also called as phase control. The reason for naming this as phase control is the instant at which the AC is put into conduction or AC is supplied to the rest of the circuitry or to the load, or in other words, the instant at which the load sees the source. Sees meaning receives power from the source directly through the switch. That instant is going to be controlled. Therefore, you call it as phase control. Right? Effectively, when you look at the current through the load, then that phase angle of current can be adjusted, though it is DC in nature. If you look at the AC side, then the phase angle can be adjusted when you vary the instant at which you turn. So you call it as phase control. Therefore, these controllers, these power controllers are also called as phase controlled rectifiers. They are also known as phase controlled converter, phase controlled rectifier. Phase controlled converters or phase controlled rectifiers. And the instant at which we turn on the device, that is termed as firing angle or delay angle. These are few terms that you need to understand with regards to controlled rectifiers, phase controlled rectifiers, firing angle or delay angle. This is referred to as alpha, indicated as alpha. Right? Instant at which the power device begins to conduct. Generally, we will be using SCR as the power device. Because if we use MOSFET or IGBT or MOSFET IGBT power transistor, then we need to remove the gate pulse, apply the gate pulse, etc. Whereas when we use SCR, you will know that the input is AC. So when the input supply becomes 0, then there is a chance for the current through the SCR to go down to 0 naturally. That is called as natural commutation. So when that happens, triggering becomes easier. You just need to apply gate pulse for some time and then that's all. You don't need to remove the gate pulse, reapply again. Don't do this process. Not required to do that process when you use an SCR. Therefore, we use an SCR. We can very well use a power MOSFET. We can very well use an IGBT. But then you need to apply for turning on, keep it on. The gate pulse must always be on. And then remove that when you want to turn off. That complication is not there when you use an SCR. So that is regarding the firing angle concept. Then I was talking about commutation. I will indicate commutation for now. With that, I will wind up for today. Next class, I will take up a simple circuit, which will be a half wave controlled rectifier. And then we will try to understand that circuit principle later on. I told natural commutation. Anyway, we will discuss all these points tomorrow with the help of some waveforms also. It will be easier for us. Natural commutation. It is called as, rather commutation means process of turning off. In SCR. Goes without saying. Natural means, so this is actually commutation. And why do we tell natural? The input AC has got natural zero crossing. Input AC. So this will have natural zero crossing. Which means the SCR will turn off naturally. No need to apply some force. The opposite of natural commutation is forced commutation. What is it opposite? Synonym, antonym, right? So I'll just put opposite. It is called as forced commutation. Wherein somebody has to forcefully, there has to be external circuit to bring down, to forcefully bring down the anode current below the holding current value. Only then the SCR will turn off. I'll tell you an example. Take the example of an inverter which uses SCR. What is the input in an inverter? Input of electric supply. In an inverter, what is the form of input source? Input will be DC. Inverter actually changes DC input to AC output. DC input to AC. So when input is DC, there is only going to be a constant magnitude. Zero crossing is not going to be there. So when we use an SCR in an inverter, then we need to force the current through that SCR to go down to 0. Then forced commutation is going to be used. Whereas in rectifiers, only natural commutation. So forced commutation, we use this in inverters and in DC-DC converters. Which means when the input is in DC form. So DC-AC and DC to DC converters, we use forced commutation. Only SCRs. Otherwise, we use MOSFETs, IGBTs, etc. That's all. So with this brief introduction, I will wind up for today. Next session, I'll again have a presentation. I'll present you certain other things. We will discuss single phase half wave, which uses only one ACR, half wave controlled rectifier. Okay. On this note, I'll stop for today.